Ionic bonds are formed from the attraction of positive ions and negative ions, metals and nonmetals. So for example, sodium chloride, sodium has a plus charge and it is attracted to the negative charge on chlorine. Up until now, you've seen salts formed between single elements. So this is just sodium and this one is just chlorine. However, there is a class of ions that exist that have more than one element. These are called polyatomic ions. Polyatomic ions are formed from many atoms that act together as one ion. These can form salts. Some examples of polyatomic ions would be sulfate, SO4, 2-. In our sulfate ion, we have sulfur and oxygen, but they are acting together as one ion with a -2 charge. So we treat them very similarly to how we treat our single elements in ionic bonds. All of the polyatomic ions can be found on your periodic table. So let's look at that. So if you look at the back of your periodic table, you will see this solubility chart. On the top of the solubility chart, on the top of the chart here, you'll see some single elements like fluorine, chlorine, bromine. But then next to them, with the names above them, you will see our common polyatomic ions. The first one is hydroxide. That is the name of this ion here, OH-. That is telling us that there's an oxygen and a hydrogen bound together, and that whole ion has a -1 charge. The next one over is nitrate. This is NO3-. So that's telling us that there's a nitrogen bound to 3 oxygens, and altogether it has a -1 charge. These are the common polyatomics that you will see. These are bound together through what are known as covalent bonds. So our carbonate looks something like this. If you look on the periodic table, you find, let's say, copper, here number 29, you'll see above it, there's nothing. On our other elements, there's this handy guide at the top to tell you what the charge is, but as you can see with the transition metals, there is nothing. That is because they can have variable charges. Some of them can have 3 or 4 different charges, depends on the compound that it is in. So for that, you can use the left-hand side of your solubility chart to figure out what the charge is. So you see silver here has a +1 charge. Lead has a +2 charge. Mercury has a +2 charge. There's only one element here that is shown twice, and that is iron. We've got iron 2+ here and iron 3+ down here. All the other ones are only shown once. And then at the bottom we have a polyatomic ion that is positive. This is ammonium. NH4+. It's our positive polyatomic ion. The rest are negative. So that is where you can find the various charges. With this in mind, we can now create salts. So the first one, you can look on the back or the front. Sodium has a +1 charge, and sulfate is SO4, and it has a 2- charge. So we see here that it's already written Na+, SO4, 2-, and Na+. We have 2 negative charges here, which means we need 2 positive charges to balance that out, to make this whole salt neutral. And when we write our salt formula, we have 2 sodiums and only one of this entire SO4. Let's look at 1D next. Silver chromate. So silver is the element symbol Ag, and chromate, it's not chromium, it's chromate, it's a polyatomic ion. To find the charge and the formula for our polyatomic ion, we need to look at our periodic table. We can find chromate on the end of the chart here, chromate, and that is CrO4 2-. That is our polyatomic ion. And we need the charge of silver, which we can find on the left-hand side of the column because it's transition metal. Silver has a plus charge. So from the periodic table, we learned that silver has a plus charge. And chromate is CrO4, and that has a 2- charge. Now we need to combine them together to make a neutral salt. We'll start with a 1-to-1 ratio. If we leave this as is, we'll have an extra minus charge. This one has a 2-, this one has a +1. When we combine those together, we have an extra minus charge, meaning we need one more positive charge to balance that out. So I'm going to put a silver on the other side. Remember that positives attract negatives, so you'll need to put your positives touching the negatives. Don't just put another silver out here. These will repel each other. No, doesn't go there. You have to put it touching the chromate where it's attracted to the negative charge. Then we write the formula. In my salt that I've drawn here, I have 2 silvers and 1 chromate. And we have silver chromate.